Okay, section 8.6, exercise number 10. We're asked to consider a power series and determine basically which values of x will lead to a convergent series. We do this by finding what's called the radius of convergence and the interval of convergence. In this case, the power series given is a power series in x. Look at the first few terms. If it's n times x to the n, so 0 times x to the 0, we don't have a constant term. 1 times x to the 1 plus 2x squared plus 3x cubed, and so on. And so we're asking, what values of x can we sort of plug into this series that will yield a convergent series. Convergent in the sense of, earlier in chapter 8, how we talked about convergent series. Modeling after, so for example, take a look at examples, example 862 in the text on page 462 to get some more insight into the approach here. But the idea is to make use of our ratio test, our convergence test, to study the convergence of a series and then look at the resulting limit and ask, well, what values of x would make that limit yield results of the test that imply convergence, and what values of x would yield results of our test that imply divergence. So in this case, I'm going to apply the ratio test. So we're going to look at the limit as n goes to infinity. Remember, it's the n plus first term divided by the nth term. So in this case, the n plus first term will be n plus 1 times x to the n plus 1. And then the nth term is just n times x to the n. We'll simplify as much as we can. In this case, the n plus 1 over n doesn't really simplify. And then we're left with a single power of x. The x to the n cancels most of the x's in the numerator. So as n goes to infinity, we have to kind of, figure out, the ratio test, recall, we want this limit to be less than 1 in order to imply convergence. So we want to kind of analyze what values of x will yield a limit here, which is less than 1. So recall, we want the limit L to be less than 1 for convergence. Technically, what we really want is the absolute value of L to be less than 1. In our case, the limit is just as n goes to, so it doesn't affect this x value. Or just look at the part in the parentheses. Notice that n plus 1 over n goes to 1. Yes, we could actually say equals 1 in that case. So our limit is just equal to x. So which x values will imply convergence? Well, we want x less than 1. So our series, power series, converges for any x value between minus 1 and 1. Specifically, since this was a power series in x, this implies what we have here. So our radius of convergence is 1, as we're looking at sort of the interval centered at x equals 0, and then our interval of convergence is the interval from minus 1 to 1. So we're thinking of that as an interval centered at x equals 0 and then has a radius of convergence 1. So radius means we go 1 unit out in either direction from the center. And those are not included in this case. And so we have our interval convergence and radius of convergence.